This screencast is going to introduce you to hypothesis testing. We're going to be talking about hypothesis testing for at least a couple of weeks. And so this screencast is going to kind of give you a good, solid foundation for hypothesis testing. To introduce the notion of hypothesis testing, I've got an example here. You really like to ride the bumper cars at Elitch Gardens. Elitch Gardens is an amusement park here in Denver. They claim that rides last 3 minutes, but you have a sneaking suspicion. Maybe you've ridden the bumper cars several times now, and you feel that the rides last significantly less than 3 minutes. Let's start out by assuming that the mean of bumper car rides is 3 minutes, as claimed by Elitch Gardens. This is known as a null hypothesis. It's what you aim to disprove or reject. Or if you can't reject the null hypothesis, you end up failing to reject the null hypothesis. If you cannot accumulate enough evidence that rides are significantly less than 3 minutes, then you fail to reject the null hypothesis. But you have come up with an alternate hypothesis in your head. You feel that the mean ride time is significantly less than 3 minutes. So your job is to prove or accept the alternate hypothesis and reject the null hypothesis if you want to conclude that the rides last significantly less than 3 minutes. For this example, we're going to assume that the variance is known. So from a long history of ride times, you know that the population variance is 0.05 minutes. If you rode the bumper cars once, and it lasted 2.75 minutes, so 2 minutes and 45 seconds, would you have enough evidence that rides are significantly less than 3 minutes? What if you rode the bumper cars 5 times and the average ride time was 2.75 minutes? So instead of riding it once, as in the scenario above, you ride the bumper car 5 times and you average the ride time and you get 2.75 minutes. In this case, would you have enough evidence that rides are significantly less than 3 minutes in length? I think you all would agree that the average of 5 rides, being 2.75 minutes, would provide more evidence than a single ride lasting 2.75 minutes. Maybe this single ride is just an outlier. So in general, you want to take a sample in order to do these hypothesis tests. Since we know the population variance, I mentioned earlier that we're assuming that it's 0.05 and it's known, we will base our analysis on the normal distribution. But we'll see in subsequent screencasts, we don't have to know the population variance. If it's unknown, we would base our analysis on the t-distribution. If the mean ride time is 3 minutes and the variance is 0.05, you could put together a plot in Excel, and I've done that. The following represents the population distribution for this random variable. So population distribution, again, is when we have n equals 1, we're just taking one item at a time, one ride at a time, and this would be the distribution if the mean is 3 and the variance is 0.05. Does it appear rare that a single ride time would be less than or equal to 2.75 minutes based on this population distribution? Well, 2.75 minutes is right in here. Getting a ride time less than or equal to that is shown underneath this population distribution curve. To me, that doesn't appear to be that rare. In fact, if you plug this into Excel, you would get that that happens about 13.2% of the time. So it's not rare, it's not exceedingly rare, that a single ride time would be less than or equal to 2.75 minutes if the statistics claimed by Elitch Gardens, the mean is 3, variance is 0.05, are true. However, if we take a sample of size n equals 5, we ride the bumper cars 5 times and we get an average of 2.75 minutes, then the analysis is a little bit different. We analyze this based upon the sampling distribution for n equals 5, and that's shown down here in the red line. The blue line is the population distribution. So we can ask ourselves, if the mean ride time is 3 minutes, as claimed by Elitch Gardens, would it be rare that the average of 5 rides would be less than or equal to 2.75 minutes? Remember, the sampling distribution is always significantly narrower than the population distribution, and it narrows when the sample size increases. So if we look at it now, 2.75 is maybe down here, and we've got just this tiny little region here. The probability that we would get 2.75 minutes or less in an average of 5 rides is now pretty small. And we could calculate this in Excel using the norm.dist function. Our random variable here again is x bar when n equals 5, and the probability of this occurring is pretty small, 0.0062 or 0.62% of the time. So in this case, it is exceedingly rare. This only happens 6 out of 1,000 times. Either we are really unlucky or ride times really are less than 3 minutes on average. So in this case, we would have evidence that ride times are significantly less than 3 minutes.